These are the notes for the sum of the interior angles of a polygon. So just a brief recap for what you did in class for this. So in class, you derived how to find the formula for the sum of the interior angles of a polygon. The first thing that we noticed when we derived this formula is that any polygon can be broken up into triangles, can be decomposed. So I can end up here with 3 triangles for a 1, 2, 3, 4, 5-sided figure. For a 7-sided figure, I end up with 1, 2, 3, 4, 5. And for a 4-sided figure, I end up with 2. You'll notice the triangles that I'm drawing all stem from one vertex to another vertex. It's a diagonal, but it's only from one vertex instead of from all the different vertices. So from this vertex, create the 2 diagonals. From this vertex, create the 4 diagonals. And from this vertex, create the 1 diagonal. We then know, back from Module 5, that each of these triangles has a sum. The angles add up to 180 degrees. We then notice the pattern that when I had a 5-sided figure, I got 3 triangles. A 7-sided figure gave me 5 triangles. A 4-sided figure gave me 2 triangles, which means the number of triangles that I can draw each time in the polygon is n minus 2, where n represents the number of sides. Putting this all together, I then have the formula for finding the sum of the interior angles of any polygon. It is 180 times n minus 2. And just for some shorthand so that every single time I'm doing these problems, I'm not writing the sum of the interior angles of a polygon equals, I'm just going to say sum of int angles equals 180 times n minus 2. So we're going to look at 2 examples. In the first example, we are told what kind of polygon we have, a hexagon. So the first thing I'm going to do, however, is I'm going to write my formula. So sum of interior angles equals 180 times n minus 2. And now that I've written my formula, I'm going to fill in what they've given me. They've given me the number of sides, a hexagon. And you'll remember that a hexagon has 6 sides. So I am going to replace in my formula n with the number 6. I then simplify and simplify further, and I find that the sum of the interior angles equals 720 degrees. And now to be really precise, maybe I should write a final sentence, which is to say the sum of the interior angles of a hexagon is 720 degrees. In our second example, we're going to go the other way. In the second example, we're not given the number of sides in our polygon. Instead, we're given the sum of the interior angles. So again, I'm going to start with my formula. So sum of interior angles equals 180 times n minus 2. And then I'm going to fill in what I know. In this case, what I know is that the sum of the interior angles is 1,620 degrees. So now I have to solve for n. So I'm going to start by dividing both sides by 180. Gets me 9 equals n minus 2. I'm going to add 2 to both sides, so I get n equals 11. And now I can write my final sentence. The polygon with a sum of the interior angles of 1620 degrees has 11 sides. And I've now answered the question. which was how many sides does a polygon, we should say not a sum, but the sum. So the polygon with the sum of the interior angles of 16, 20 degrees has 11 sides.